Hello everyone and welcome back. Today we're going to continue with the Class A vacuum tube stereo build. And what we're going to do, this thing, it's heavy. What we're going to do is take this thing to the bench. I'm going to show you how to put it together. Ooh, look at that. Ooh, sorry, it's shiny. What we're going to do today is we're going to take this to the bench. I'm going to show you my process of putting it together. And then at the end we're going to do a sound demo. So let's do it. The first thing is, in fact, first, you are going to want to take your nice new circuit boards from Easy EDA or your perf board, if you're going to build it that way, and give it a nice inspection, make sure everything looks hunky-dory. You can even trace out with your board outline if you like. And I'm going to recommend that you start with the low-profile components first, like diodes, resistors, anything that's low to the circuit board, because if you don't, you're going to have a bad time. Start by bending the leads, preferably not putting stress on the body of the component like I did. Line everything up, make sure that you have the device in the right way around. Diodes do have a direction. And because this diode is actually meant to dissipate heat, I'm going to lift it off of the board a little bit so that there can get some airflow in there. Bend the leads out. This is not only to make soldering easier, but this is going to provide a mechanical connection. Wick up the tip of the iron. Dwell for a couple of seconds. You don't want to dwell too long with these because silicon devices are more prone to heat sensitivity. But because the leads of this 6 amp diode are so thick, you're going to want to wait a little longer to make sure you don't have any dry joints. All right, you can see the joints are nice and shiny. I actually clip a little closer. Ideally, you don't want to actually clip onto the joint that you make, the solder joint, because you could potentially rip the pad. You could actually pull the pad up by doing that. You're putting unnecessary stress on the joint. So clip it higher. Also, you see that flux splatter? Yeah, clean that up as soon as possible. You're never going to get that off if you wait. Carefully place the stereo on the table, taking a quick look at the tubes. Oh, don't they look nice? Nice and shiny. This switch, like I said, has a headphone setting, a neutral or no connection setting, and a speaker setting. Getting the tubes out of the way here, 2 of the EL84s to show you the star of the show, the LM317 voltage regulator used as a current source and shunt with a nice big heatsink. In the back you can see the 3 relays that control the auxiliary input, the RCAs, and the Bluetooth. Here's that solid capacitor. And here we have the bias for the tubes, but you do not want to touch these once you set them. Actually, I should have probably just used fixed resistors for this once I found the right setting. But if you do have to adjust them, you're going to use a multimeter. There's a 1 ohm resistor, as you saw in the schematic there. You can use that to set the bias. In the back, we have the brains of the operation. We have a Atmel 328P, the chip used in the Arduino. In the back, you see the cables for the VFD. Left and right output transformers, and as well as the power transformer. Just gonna give this a spin around because it looks awesome, but no, I'm just kidding, it's boring back there as well, but just wanted you to see. Now we're gonna take a look at underneath, and you can see my beautiful wiring. Which this amp is extremely quiet, but there is a tiny bit of hum, and I'm assuming it came from this terrible wiring job. Up top we have the high voltage and low voltage switches, an indicator. At the bottom we have a fuse, which is coming from the power input jack. Here is the selector switch, as well as the headphone out, the RCA in, which like I said has just been converted to normal use as an auxiliary in. Here is the Shure Bluetooth module that I purchased. You can see 2 wires running to the power supply, 12-volt rail of the power supply, as well as a cable going to one of the relays. Here you can see the 4 wires for the 2 speakers. And up top, you can't see it really here, but here are the wires that run from the Arduino to the vacuum fluorescent display. This is the 100k ohm potentiometer. It's actually a dual gang, so 2 potentiometers in one case. Allows you to control left and right volume. You can see the mounting locations for the transformers. Missing a screw there and a nut. Not really sure what happened with those, but a little bit of heat shrink just to try and tidy things up. Like I said, some of this, I tried my best to plan this all out, but it just you don't really have a lot of tries, and once you commit, you really commit. So you want to twist any power wires and ideally run them as close to the chassis. Over here is the power supply with all the big capacitors filtering. Here is the 5-volt power supply that I forgot to put a heatsink on. It gets very hot, unfortunately. That was quite a big oversight on my end. Anywhere I'm passing wires through the chassis, the aluminum chassis, just to prevent any cutting or scraping of the insulation on the wires, I have installed rubber grommets, rubber feet on the bottom that came with the enclosure. And here are the 2 resistors that I recommend you bump up to at least a watt, because they do get very hot. You can actually see they're already starting to turn brown again. These are still the half watts. A rule of thumb, if you're going to be measuring anything inside of this device on top or bottom, what you're going to need to do is do what I do and use a alligator clamp for the negative or one of the connections. So you only need to use one hand on the positive probe when you're testing, because the last thing you want to do be the path for current to flow, because you're going to get hit hard. So it's better to have your finger, get the jolt rather than having it pass through your chest and causing a lot of problems there. And at last, the moment you've all been waiting for, we are going to do the sound demo now. I have some royalty-free music, courtesy of Spotify, and we are going to give this thing a listen. So I am going to get the microphone set up. It's not going to be ideal. I know this isn't going to be great representatively, but I just want you guys to hear how loud this thing is. Like, it's really impressive for a small apartment like this. So first, we're going to start off with some quiet classical music, just to set the mood. Romantic orchestra. All right, next we're gonna do a little bit of EDM, something with a bit more bass to it. Now, because of the output transformers, you are gonna lose a little bit of bass, but this circuit does have a place for you to hook up a subwoofer, which is awesome for music like this. All right, guys, thank you very much for watching this video of me building my Class A vacuum tube stereo. Let me know what you think. Want to see more content like this? If you have any suggestions for me or anything in particular you would like to see, if you look just behind me here, you'll see my blue 512 LED cube, which is another project I've been working on. I've been meaning to get back to it. I put a little bit of it together and have been doing some testing, but let me know if that's something you'd like to see in the next coming weeks here. Also, if you have any questions about electronics, or if there's a particular topic you'd like me to talk about, let me know either in the comments of this video or by sending me a message via YouTube. Maybe you guys can kind of help me discover what I would like this channel to be. Like I said, I'm not really sure of the exact path I'd like this channel to go on, but if you have any ideas, I'd love to hear it. And thank you very much, guys. This is going to end the build for today. Thanks for watching. Bye.